Data scientists often do a lot of their work as batch processes written in Python, one form or another. When they want to migrate that to real-time systems, they can use any language they want as long as it's Java. That's not always a super comfortable move, which is a problem Bytewax is trying to solve. Today I talked to Ali Makhasoeva. She is the Director of Developer Relations at Bytewax, all about that library and approach to stream processing in a Python native way. Let's check it out. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and I'm joined today by my friend, Ali Makhasoeva. Ali is the Director of Developer Relations at Bytewax. And Ali, I am really glad you're on the show today.
Yay! Hello, everyone, and I'm really happy to be here, and I'm honored to be a guest and represent Bytewax as well.
Excellent. Well, it's been too long, so good to see you and catch up, even if I'm seeing you on a screen 4 feet away from me.
Yeah.
So you are at, how long have you been at Bytewax?
Since December. Right?
Yeah. Okay. So about 6 months.
Yeah.
And I know what that's like. I've recently been new at a new company at StarTree here for a little more than a year, but I definitely know what it's like to jump into a new part of the ecosystem and a new technology with all kinds of new details and master all that. And tell us about Bytewax. What is it? Is it?
It's a new startup. Not only I joined it recently, but also I joined it as a founding member of a DevRel member. So we're just starting here and trying to find the message and everything. But overall, our mission is to make data streaming more accessible for Python users, by which I mean that even though there are a lot of solutions and they're good for many use cases, still we found this niche where we want to basically scale one Python developer, meaning that we the founders of the company, the first developers, they worked on bigger projects with GitHub, for example, and they were data scientists there, data engineers, and they saw that when data scientists working on their problems and want to use that solution in a real-time context, they start to looking for tools that they could use, and the kind of canonical example would be to use Apache Airflow as the so they would use that to build DAG graphs and send workflow, and they would do that in batches, like every once in 24 hours, and then they would be like, oh, I want this more often, and they would just change how often the Apache Airflow would run. And eventually it actually looks like, I want this job running like every 0.0001 millisecond, whatever. And then they start to look for solutions, and Apache Flink comes to mind, of course, because that's what industry uses. And here there is a problem. If you're a data scientist, there is no guarantee whatsoever that you ever worked with JVM. You know how to tune it, and that's a big chunk. And you're like, oh my god, that's overwhelming. Do I hire people who are professional in it? Do I start to learn? And the learning curve is steep. So basically, you as a member, as a data scientist, data engineer, Python user, you're just overwhelmed with the amount of effort you need to put into making your solution, application, whatever, real time. Make it work in real time. Yeah.
as a data scientist, you do all this batch work in the data lake
Yes.
and interesting tools. You do it all in Python and you love your life. And now it's like the CTO says, great, now make it real time.
Yes.
Okay,
And
well,
so,
you can do that in
yeah.
any
And
language
as
you
I
want.
said, yeah. And as I said, the obvious solution is Flink, but then you have to bring this entire ecosystem. And then how do you like run a cluster, send your fed jars there, and then it starts to it wants to run your Python, and all of a sudden your Python dependencies are not there, so you're just like, oh my god, I need to install all this pip install blah 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 on all my nodes. What do I do? And then Flink a little like it's mature, I should say, and doesn't work as easy with Kubernetes, for example, as some newer tools. So that's another problem. And basically, Bytewax is trying to serve these people who face this problem that they want from their Python code in Python ecosystem and have less
Flink for
problems.
Python.
There is PyFlink though,
Okay.
but so I have to make like a little. I'm not a Python developer. I've been doing Scala, JVM more, and I might not explain that correctly, but PyFlink is the basically wrapper around, like it's an API, which is not which still makes a difference between like Python first solution as
Mhm.
Bytewax and like something, I hope like
Yeah, Python native.
Python API for Kafka, for example, which uh, also same thing, right? You have JVM solution, and then you try to connect to it, so it doesn't
Yeah,
eliminate the problem of dependency management and
exactly. And
two ecosystems.
the Python library for Kafka isn't a stream processing library. It's just
Yeah,
a
yeah.
it,
I mean, it's just an example I was trying
yeah,
to give as a when you have like two ecosystems in your project, and when you
right.
don't necessarily want this. So yeah, the appeal is to lower the barrier.
Uh-huh.
Yeah.
So that the Python native life of the data science team can move over into the real time world of event processing. And I mean, I guess presumably you would assume there's a Kafka cluster out there somewhere,
Yes. Yeah.
probably,
Something.
and
Yeah. Yeah.
you just don't want to make these poor people do things in Flink or Kafka streams and learn a whole new
Yeah, yeah,
ecosystem.
yeah.
Yeah,
So, in terms of that, yes. So we have to keep in mind a little bit that we also kind of focus on things that are stateful,
Mhm.
because if you have Kafka cluster and you just want to filter, transform, whatever, and send it, like you don't care about state, you can just do like whatever solution you want. Actually, just send this to like Python microservice and send it back. So when you don't care about your state, there are simple solutions. It's not like
Yeah,
you
the
have to
regular
think
Kafka
about like
Python
what could you.
library is going to be fine in
Yeah,
that case.
yeah,
If you want to
and
do
you
it,
just do that. Yeah, and Python
those things.
care, Bytewax cares about like state. We're trying to think about like window and recovery. At the same time, like correctness of what we do inside, and convenience too, because again, this could be solved with Flink, but convenience there, because we are actually, yeah, I have to do a step back. We use timely data flow
Mhm.
engine inside, which is written in Rust. But
Oh,
because Pio 3 exists, it allows to do like bindings and all this stuff. And basically, you can use Rust inside Python in a very ergonomic way. And even when you install Bytewax, for example, it just needs, because of the project called Maturin, I think, uh, all you need to install it, you just go and do like pip install Bytewax. And there is a bunch of different libraries that use that. Rerun is another one that comes to mind. It's a library for visualization. But basically, yeah, that helps to use some capabilities of this timely data flow engine and bring them into Python world. Yeah. If we were talking about like wrapping up the Flink, then you still have to deal with the JVM ecosystem
Right.
and like how you install
Right.
it and everything. But here you don't have to worry about Rust that much because it's leverages PyO3.
Yeah, it's in the binary, as it were, and you don't have to worry too much about it.
Yes.
I wonder if from like I'm curious from an API standpoint, and like I said before, I'm not a Python developer. I mean, I've hacked this, that, and the other thing, but I'm not super fluent in that world
Guess
either.
what, Tim? Guess
Yeah,
what?
right.
Me neither.
Working in a company. And I haven't made any jokes about Scala yet, and we've been in this 10
Yeah.
minutes, and I've made no jokes to the extent of Scala. I'll get there. I'll figure out a way to do that.
Okay.
And
No problem.
if Victor were here, then obviously it would have happened already. It's just
Yeah.
I'll make sure that I do that to his satisfaction. I feel like he's going to be listening, and he'll need that to happen. But from a API standpoint, there's like what's it like to write code with it? What are the things I can do with it? What does it do?
Okay.
And
So
then from an
basically,
operational standpoint, how does it run? They're kind of my two areas of curiosity.
okay. So basically, you can build your data flow, and data flow is just, so you basically connect to data flow with your, like, using operators, and operators can be like input operator, read from Kafka, read from this WebSocket, read from whatever. Then you can do like a regular operations like filter or map or stateful map or like different things. And it also can remember the state, and recover from it if something goes wrong. And then you just send that downstream with output or like print, whatever. Yeah,
There you go. So you
some
got
of
the
the,
good old input, do stuff, output. That's kind of the Kafka Streams
yeah, yeah,
model.
yeah,
It's
yeah.
kind of the Flink model. This is how one does, I guess,
Yeah,
computing, but also stream processing. That's the way it happens.
yeah,
Um,
and mm, probably the most interesting operators like joins and things like that are still ahead of us. And
okay.
also, it's still a linear data flow for now, but on our roadmap to make some, more like sophisticated data flows so that you could send that to like different parts of data flow. And in terms of how running, we have this WaxCTL tool that helps to work with Kubernetes. So you can do that natively. And recently we started like we started calling for people to use our platform. So if anyone interested, they can go to our website, bytewax.io, and find and sign up to test our platform. So it's just like a beta. So it's a really fresh new product. So we haven't like started doing, like we're still in, in progress type of
Absolutely.
thing.
Early
But
early days
yeah,
still.
yeah, early days. But we're excited, and we see like interest from the community, and people are, you know, found their tool.
Cool. You mentioned stateful things, and I know
Yeah.
it's early days, but you said, I forget, there was one of the things you said that was a stateful map. Like what's
Yeah.
the current support? What are the stateful operations? Those tend to be where things get interesting. So what's the current state of that stuff?
Wh- Like you mean in like what are the tools that people use for the stateful map, and or
In
how it looks in
what are the
in
yeah, what are the stateful things that it does? Maybe tell me what a stateful map is, because that sounds like an interesting.
So basically, the difference between just the map is done when you have an element, you do an operation, and you send the result downstream, right?
Right.
So you don't care what was before, what was like, what was happening, and you
Each
just do
message stands alone.
everything
You
like
just do your
step by
thing and
step, right?
yeah,
Yeah, and
stateless.
with the
It's a great life.
yeah, yeah, exactly. And stateful, it has accumulator that you care about from the previous state, and you can use that in your calculations. I thought for a second that in the new version we used something, we added something else, but we didn't. So apologies for like, it just and it's commonly used for example, for anomaly detection. When you see the previous state, what the average was, and you could compare that to like your current state, and you can see that your outliner, for example, and things
There
like
you
that.
go. It moves outside the
Mhm.
moving average or that kind of thing. Okay,
Yes, yes,
cool.
yeah, yeah,
Cool.
something like that.
Um, and question, I don't know if you know, and I know
Hmm.
I certainly don't, is can you, when you have that stateful map,
Hmm.
can you get at the elements in the map? Can you like from outside that go and look and see like here's the current average, or is it just available
Yeah,
in context?
there is accumulator in
Nice.
uh yeah,
Yeah,
yeah.
I just recorded an episode a few days ago with Bill
Hmm.
Bejic. He's a Kafka committer, and we talked about the Kafka Streams interactive queries thing, which is that same thing where you've got state that you've accumulated and you want to like go query it.
Hmm.
And that's a way, you've got events happening in your event stream, and you might want to make the current state of the average or whatever it is queryable, right? Like you want to ask a question. So
Yeah,
that,
yeah.
and I know you and I talked about this before the recording. I've been on this kick lately on the podcast thinking about querying streams, because streams themselves, and you mentioned two very different kinds of inputs. You said Kafka and WebSockets, and
I
I
did
assume there
that
are
on purpose.
exactly, yes. This is not just a Kafka thing. There's things happen in the
Yeah,
world, and you have other, you don't care where the events come from. You just want to provide
yeah,
a
yeah, yeah.
Python native way to process them. Um, so that stream though is you just get the next thing. It's a log. It's not a thing you can ask questions about. So when you want to make it queryable, um, what do you do? Or maybe the better way to ask that question is, and I just want to kind of get your thoughts on this. When do you do one versus the other? Because I might take a stream and dump it into a Postgres table or something, or I might
Hmm.
I might ingest it into Apache Pinot, and have all kinds of funky indexes and complex queries, and it's like go be a database. And when do you think about how to do one versus the other? Because you are on the more stream processing end of things, and these are both tools that we need. So how do you think about when one tool is applicable versus the other?
So I don't think I decide between one or another necessarily. I probably need them both. But if we talk about particular challenge, I'm gonna use something that our CEO Xander was talking about at Data Council. He had a talk there, and he was talking about how um, like analytical systems are different from operational. So he classified these two things into two buckets, and basically they both are care about like freshness, because it's like a you need something in real time. And it needs to be fresh, so low latency, freshness. And the third point is different for these two kinds of systems. One is that retrieval, when we want to answer questions that we want to think, like, for example, why 50% of our customers do that or this or like whatever. And then you indeed want to use like Pinot or Postgres, whatever, load your data, think about this, do analysis and things like that. But when you care about reactiveness, when you want to get the reaction on something in real time by machine, not necessarily a person, then it comes to stream processing. Think of two examples. The first one is, and I do that on purpose, is who viewed your profile on LinkedIn.
Just
so
ran off the top of your head. Yes, go on.
It's actually, he used that in his talk, and it's interesting. Yes, it's interesting because I was like, well, it's Pinot.
If you don't know, if you're listening, that's part of the origin story of Pinot, and we've talked about that on previous
exactly. And yeah, I was surprised to see that, but and then I learned about, like, I don't even remember which order, but anyway. So if you view something, you like analyze that, and that's no actual reaction from you on this information. Like, nothing happens in real time for you. Like, you can like, do your decision based on that information because it came to you in real time and something. But actually, there is a human input in that. Mm-hmm. Versus, for example, with this anomaly detection, let's think about fraud detection in bank. Mm-hmm. When they run through a transaction and they see something looks like a fraud, like unusual usage of your card or whatever, they just block it immediately as a robot. And then they send you like a text message and say, hey, we think it's fraud. Can you confirm it's not you, or like whatever? Right. And then they change this, but initially they react immediately. Like, they change it and you go. So these are two kind of different cases that I think of, like reactive versus retrieval. Like, when you ask many questions about the same like span of data and things like that, versus like when I need to react immediately.
Yeah, it's interesting because, like, I want to say, if a machine is reading it, it's a stream processor. If you're serving it to a human, it's a database. And that covers a lot of the cases. But sometimes a machine is reading the database. Like, if you're doing anomaly detection in Third Eye, which is our anomaly detection layer on top of Pinot, well, the machine is reading Pinot then. But in any case, if it goes into a database, it doesn't go back into the streams. I think that's part, your output.
Oh yeah, terminal. That's what I wanted to say, that it's terminal for the process. Like, after you saw that your like how many people saw a page, it doesn't go back to the stream, and it doesn't say. Versus when you send this text message back and say, hey, that's me, then it can do something. Or another example is the automatic stock market, when it goes and the system reacts, robots react, and it goes downstream. And what?
Yeah, good. That all that.
Yeah. So also, there are other dimensions like your team and exposed APIs. Some people prefer and feeling more comfortable working with SQL-like APIs, and that's what they want, right? Or like, also based on different ecosystems. Like Python is really good for like many things, and the ecosystem, especially in machine learning and everything, it has many libraries. Maybe people want to stick with it, maybe they want something else, and yeah, so many things.
They want the flexibility of how to think about that computation when they're in the middle of some process and their outputs are going to go somewhere else. Yeah.
But still, I wouldn't think that it's exclusion if you use something that you like use only that. No, like
Right. They
I
would
think
be two tools that you're going to solve different. You're going to have both tools in your system, and you're just going to solve different kinds of problems with each one.
Yes. Yeah. Exactly.
My guest today has been Ali Makhasoeva. Ali, thanks for being a part of the Real-Time Analytics Podcast.
Thank you.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.